Okay, so we're going to go through a simple quick lesson to make sure that we understand circuits properly. So let's start off with a simple circuit diagram. Um, we're going to just create a circuit diagram where we'll have a battery source. Remember, the big line essentially signifies a positive terminal of a battery. The small line is essentially a negative side to the battery. We're going to draw a case where we have a very simple resistance, and we're going to complete the circuit here. Okay, now um, one quick thing in terms of numbers, we're going to supply a simple voltage of 10 volts in this case. Okay, and the total resistance here is essentially 5 ohms. Now, as part of the process, I want to make sure that there are 3 questions that the circuit lab folks will ask you, right? Number one, the first question they're going to ask about is essentially, what is the current? Okay, so the first question would be current in this circuit. Okay, I can't spell right, but I think we'll try our best. So this is a current. So what is current? Now current in this case is flowing from positive to negative. So current is flowing this way. All right. Now note the electrons are flowing from negative to positive, but the convention in electrical circuits is that the current flows from positive to negative. So current is flowing this way. Okay. Now, in order to compute current, what we are looking at is a simple process of Ohm's law in order to figure this out. And what is Ohm's law? So let's say now we need to figure out what I is. We don't know what I is. So in order to figure out I, we apply Ohm's law. Now, how do we apply Ohm's law? Now remember, it's a simple circuit. We have one resistance. You have 10 volts that are feeding into this 5 ohms. And by Ohm's law is simply V equals to current times resistance. Okay. Now, if it's equal to current times resistance, we know what the voltage is, we know what the resistance is, and we should be able to figure out I. So voltage here is simply 10 volts. The current here is an unknown. We don't know what it is. And the resistance here is 5 ohms. Okay. So what is the current? Current is simply equal to 5, or rather, sorry, 2. Let me just erase it. And current is simply equal to 2 amps. Okay. So now remember the nomenclature, which is very important. The A is important to signify amps. Okay. So let's just go through this circuit one quick time. You have a voltage of 10 volts. You have a current of 5 ohms. You have a current that's going from positive to negative. The first question they're going to ask you in Science Olympiad is, what is a current? And current can simply be solved by V equals to IR. And since we know the voltage, we know the resistance, current is equal to 2 amps. Okay, so let's just put that down. I equals to 2 amps. And let's go to our next step that is going to be asked in Science Olympiad. Okay. Okay, so this is all erased now. Now let's do the second part to it. Now the second part is going to be, what exactly is, so the second part that they're going to ask would be, okay, so now we know the current is 2 amps. What is the voltage drop? Voltage drop across the 5 ohm resistor. Okay, resistor. Now remember, whenever someone is using the word voltage drop, it simply means that if you were to connect a voltmeter here, what would it measure? Okay, so I know this term could be a little bit deceiving, but voltage drop is essentially how much voltage is across a 5 ohm resistor. Okay, now you can do it 2 ways, but it's a pretty straightforward component of it, right? The voltage drop is simply equals to, again, Ohm's law, current times the resistance. Now the current is 2 amps, the resistance is 5 ohms, and therefore the voltage drop is simply 10 volts. Now remember, why is this 10 volts the same as the 10 volts above? The reason why the 10 volts here is the same as the 10 volts above is simply because this is the only resistor. So all the voltage is being taken by the 5 ohm resistor. Okay, now that is the second question that they will ask you. All right, now let's go through the third option. All right, okay, so now we're going to go through, erase this part here. Okay, I'm going to try and erase this carefully. Let's hope we work. All right, good, that works beautifully. And now let's look at our third question. The third question they're going to ask you is going to be, what is the power that is being consumed by the 5 ohm resistor? Now remember, what is the formula for power? Power is equal to simply voltage times current. Okay, do we know the voltage? So now remember one thing, what is the voltage here again? Any point in time when we're saying voltage, it's essentially putting a voltmeter around the 5 ohm resistor. Okay, so what is the voltage across a 5 ohm resistor? We know that the entire 10 volts above is feeding into 5 ohms. We did that in the last part of it. Okay, another way we can say it, in the last one we said the V voltage drop across a 5 ohm resistor was 10 volts. Remember from the second part that we just solved. So what is the power across the 5 ohm resistor? Is going to be voltage across the 5 ohm resistor times the current that's flowing across the 5 ohm resistor. And therefore this will be 10 volts times the current. The current is 2 amps, and therefore the power is equal to 20 watts. Okay, power is measured in watts, and therefore the power across the 5 ohm resistor is equal to 20 watts. Okay, all right, now we're going to go through the second part to this. All right, now the other part, now the next part to it is that they're going to ask you guys what is the energy that is being absorbed by the 5 ohm resistor. Now remember, the 5 ohm resistor, when you touch it, it's going to be a little warm, okay, because it has current that's flowing through it. Now remember, the formula for energy is simply equals to power that is being used by the 5 ohm resistor times time. Okay, now in this one particular example, let's assume for now that we run this for let's say we run this for 60 seconds. Okay, we run the circuit for 60 seconds. So we know that the power across the 5 ohm resistor is 20 watts. So that'll be 20 watts times 60 seconds, which is the time, which comes to around 1200 joules. Remember, energy is measured in 1200 joules. Okay, so what we've done in this problem at a high level is that we've taken a simple circuit problem where the battery is 10 volts, a resistance is 5 ohms, and what we've done first is to measure current. Now we know current moves from positive to negative. Number two, we know that the formula for current can be solved by Ohm's law. We know that for this entire circuit, in order to come up with the current, we have a voltage of 10 volts, a resistance of 5 ohms, and therefore our current is 2 amps. So that seems reasonable. Okay. Now, the voltage drop is a second question. What is the voltage drop across a 5 ohm resistor? So what does a voltage drop mean? A voltage drop, in essence, is simply if you were to put a voltmeter across the 5 ohms, how much voltage would it measure? Okay, that the voltage is dropping. That's the reason why the voltmeter measures the voltage. And what the voltmeter essentially calculates this is going to be based simply again on Ohm's law, which will be current times the resistance, which will be 5 ohms times 2 amps or 10 watts. And that is identical, or the, sorry, 10 volts, I mean, not watts. And that is identical to the battery that's feeding it, because there is no other resistor in the circuit. So the entire 10 volts is being taken by the 5 ohm resistor. Okay, so the voltage across a 5 ohm resistor is simply 10 volts. Number third is power. Power across a 5 ohm resistor is simply voltage times the current. We know the voltage across the 5 ohm resistor is 10 volts. We know current is 2 amps. Therefore, 10 times 2 is power, which is going to be 20 watts. And then last but not least, energy across the 5 ohm resistor is simply power times time. In this example, it will be 20 is the watts is the power, time is 60 seconds, and therefore the energy that is dissipated in 60 seconds is 1200 joules. Okay, well, I hope this was helpful, and let me know if you have any questions.